Okay, hello everyone. All right, so the next program in chapter 7 is gradebook. All right, so a teacher has 5 students who have taken 4 tests. The teacher uses the following grading scale to assign a letter grade to a student based on the average of his or her 4 test scores. So these are the test scores and then these are the letter grades. So write a class that uses a string array or an ArrayList object to hold the 5 students' names and an array of 5 characters to hold the 5 students' letter grades, and 5 arrays of 4 doubles each to hold each student's set of test scores. The class should have methods that return a specific student's name, their average test score, and a letter grade based on the average. Demonstrate the class in a program that allows the user to enter each student's name and his or her 4 test scores. It should then display each student's average test score and letter grade. And so we have an input validation here, which basically says we shouldn't accept test scores that are less than 0 or greater than 100. All right, so we're going to go ahead and create 2 files. The first file is going to be the gradebook class, and then the second file is going to be the program that's going to test the gradebook class. So let's go ahead and do that. So first of all, let's start with the gradebook class. So I'm going to go ahead and create a public class, and I'm going to call it gradebook. Now it's public because we want code outside of this class to be able to access this class. That's why we are setting the access specifier to public. So let's see, write a class that uses a string array or an ArrayList object to hold the 5 student names. So up till now we've used regular arrays to store information. So let's go ahead and use an ArrayList object, since we've never used it in chapter 7, to store the student names. Okay, and maybe going forward we'll also start mixing regular arrays with ArrayList, depending on what we want. All right, so before we can use our ArrayList, or before we can create an ArrayList, we need to make it available to the program. We need to import it to this program so the program can have access to it. And to do that, I'm going to use import java.util.ArrayList. So what we've done is we've imported the ArrayList class located in the java.util package located in the Java API. So now that we have access to the ArrayList class, we can go ahead and create an ArrayList. And so I'm going to create an ArrayList class type variable or a reference variable. So ArrayList. We are creating an ArrayList that's going to store strings. So I'm going to specify the type as string. And I'm going to go ahead and call this student names. Okay. And I'm going to initialize it. Oh, well, I'm not going to initialize it. I'm going to now create the object. So this is just a class type variable or reference variable that is going to hold an ArrayList object. Now let's go ahead and create the ArrayList object. So I'm going to use a new keyword to create it. I'm creating a new ArrayList that is going to hold strings. So I specify the type string. And because this object is going to be created with a constructor in the ArrayList class, we have to bring our parentheses. Okay. All right. So over here, it continues by saying an array of 5 characters. Oops, I forgot something very important. I need to also specify the access of this. I need to specify if it's private or public. And let me just do that now. So this array here is going to be a private field, and I'll explain that in a second. So private, everything stays the same. So private ArrayList, okay. Private because we don't want code outside of this class to be able to directly access this ArrayList. We want to create methods in this class that are going to be used to access information instead of directly allowing code outside of this class to access this field. We are hiding this field for now, and then allowing methods that we are going to define later on in this class to basically access the field for any code outside of this class. Okay. All right, so that's important, private. All right, so let's continue. An array of 5 characters to hold the 5 students' letter grades. So since it's going to be an array that's going to hold characters, let's go ahead and create a character array. So that is also going to be a private field. So private character or char array. So private char array. And let's call it student letter grade. And over here now, let's go ahead and initialize it. Okay, If you want to initialize it right away on this line, you don't have to use a new keyword. You can just use your curly braces and then, insert your values in here. So I'm going to store the letter grades, these letter grades in here as characters. So A, oops, S. My typing is still bad. A, B, C, and then so on and so forth. And then F. Okay, so we have that array also set. All right. And it says, and 5 arrays of 4 doubles each to hold each student's set of test scores. Now, the first time I saw this, I thought directly hard coding 5 arrays of 4 doubles each in this class will make the program very, very fixed. We want the program to be flexible. What if we wanted to create an object from this class that represent 8 students who have 2 scores each, or 100 students who have 3 scores each? We want the program to be flexible instead of hard coding these 5 arrays of 4 doubles each, in here, right? Then the program can only handle 5 students and 4 scores. So instead of creating the arrays directly, let's create a two-dimensional array that is going to hold the student scores, and basically the scores of one student is going to be an array that sits in the bigger array. So it's a two-dimensional array. It's basically an array of student score arrays, right? An array of arrays. Okay, the outer array contains all the student scores, and each of the student scores is an array on its own. So let's go ahead and define the array, and later on we'll talk about the details. We'll work with the details to understand how it works. So I'm going to also define that as a private field. So private, and then it's going to be a two-dimensional array. It's going to hold scores, right? It's going to be a double array, but it's going to be a two-dimensional array, so we have to use 2 of these. Okay. And then let's call this, let's call this student test scores. Let's not initialize it now. Okay, we'll come back to this. So let's move on. So let's because over here it's saying we should create 5 arrays of 4 doubles each. We've settled that for now with a two-dimensional array. We'll come back to it and it will make sense. The class should have methods that return a specific student's name. Okay, so let's work on that. So if it's going to return a specific student's name, that means it's going to get information, right? It's going to get information from a field of this class. All right, so it's going to be a public field because we want code outside of this class to be able to use this method. So it's going to be a public method, not a public field. It's going to be a public method because we want code outside of this class to be able to use this method to fetch information. So it's going to be a public method. Now it's not going to have the keyword static because this method we are about to create is an instance method. Instance methods are methods that work directly on a field, of a class. And because this method here is going to work directly on the student's name ArrayList, which is a field of this class, it's an instance method. Instance methods don't have the keyword static. We'll leave it in for now. We'll leave it for now, and later on, later on in future programs in different chapters, you will see why. You will have more information. But for now, instance methods do not have the keyword static. So no keyword static. Public, we need to specify the return type. The program over here said the class should have a method that return a specific student's name. So it's going to return a specific student name, which is going to be a string because we know this array list is going to store strings. So the return type of this method is going to be a string. So public string, and then let's give it a name. Let's call this get student name, right? This is just the name we are making. So get student name. All right, so let's see if it's going to need any parameters, right? So the array list, has a method called get, that gets a value in an array list based on its index, all right? The first element in an array list has an index 0, second element has an index 1, so on and so forth. So if you use the get method on an array list and you pass in the index, it will return the value at that position or at that index of the array list. And so if we're getting a student name from the array list, we need to specify its index, right? Whoever is calling this method needs to provide the index so we can fetch what's in that position of the array list. And so an index is going to be an int. So let's define a parameter here. It's going to be of type int, and we'll call it student index, because that's going to be the position of the student. And over here in the method, we're going to call the ArrayList get method. So it's going to be student names. That's the name of the ArrayList. Even though the ArrayList doesn't have anything stored in here, later on, before we call this get student name method, it will have values. Okay, so we're going to call student names dot get, right? And we need to provide the student index that whoever called this method provided. So I'm going to copy it and paste it in here. Right, so this is going to basically fetch the name at this particular index. What we want to do is we want to return it. We want to return this information to whoever or whatever code that called this method. So I'm just going to directly attach the return statement here. We're returning this information to whoever called this method. So I think we're done with this. Okay. So the class should have methods that return a specific student's name, the average test score. So we need to also create a method that's going to return the average test score. So the average test score is going to be it's going to work on the scores in the student array, right? So let's see. So let's go ahead and construct it. So it's also going to be an instance method. It's going to be a public method because again we want code outside of this class to be able to use this method to fetch information. It's going to be a public method, no keyword static because it's an instance method. Now if you think about it, right, we are calculating the average test score, which is going to be a double. And so we need to specify the return type of this method as a double, right? And so it's going to be public double. Let's call this calculate average test score. Now you can use whatever name you want here. I like to use long names because it helps with me understanding the program more. But call it whatever you want that makes sense. It makes sense to you. All right, so let's see if this is going to accept in any argument. When someone calls this, and yes, it's going to accept an argument because we need to pass in the scores of that particular user so that this method can calculate it. Now we are creating a two-dimensional array here, which is an array of arrays, an outer array that contains several arrays, and each array contains the scores of a particular student. So that means that in one array, one array will contain, let's say, 4 scores. According to this question, 5 student, which is 5 arrays of 4 doubles each, to hold each student's set of test score. So one array will store the student's test scores, which means that we need to pass in the array. We need to pass the array to this method to basically fetch the information in that array, and then calculate the average test score. And so we are going to define a parameter, and that parameter is going to be an array, of doubles. It's going to be a double, It's going to be a double array. It's going to double one-dimensional array because this student test scores is an array of one-dimensional arrays. So it's going to be a double a one-dimensional array. And I'm just going to give it a generic name of a particular student, test scores, right? Student test scores. So student, because this is going to be one particular, let's see. Student test scores. I guess you can make the students test scores. Student test scores. It doesn't matter, right? This here is representing all the students, and this here is a particular student. So you can name the students if you want. But I'll just keep mine as student. You can, but it's good I've explained so you understand now. This represents all the students' test scores, and this represents one particular student's test score. I know it's a bit confusing there. All right, so now we have access to a particular student test score. Now we have to loop through it to get the values and then calculate the average. And so let's do that. I'm going to create a for loop that's going to loop through this particular student test score array, right? So I'm going to, first of all, create a target variable that's going to represent the index of each score. So I'm going to call this for int current student test score is equal to 0. Now, each element in an array has an index, similar to the array list. Each element in an array has an index. The first element in an array has an index of 0. Second element has an index of 1, and so on and so forth. The last element has an index of 1 less than the length of an array. So if you have an array that contains 4 scores, the index of the fourth score, okay, which is the fourth element, is going to be 3. The last index, okay, or the last element will have index 1 less than the length of the array. The length of the array is 4. The index of that particular fourth element is going to be 3. Okay, 1 less than the length of the array. So what we are doing here is we are using this variable, okay, to keep track of each particular score. Okay, we are keeping track of we're keeping track of each particular score using the index. And so over here, for int current student score is equal to 0, as long as the current student test score is less than the length, okay, of this array. So I'm going to use the name of this array. It's less than student test scores dot length. I was just thinking about these names again and how it can be confusing. It's still going to work, right? Because over here it's going to know that it's dealing with this parameter and not this particular two-dimensional arrays. On top of that, this is a two-dimensional array and this is a one-dimensional array. So the program is still going to make sense of it. All right, but if you want, you can just you make this S, or you can just call it entire student scores or something like that. Or sorry, student test scores. That's what I meant. I just keep mine as student test score. Student test scores. Student test score. It makes sense to me just to keep it as student test score. That's why I left it this way. So I hope it makes sense there. So this is going to be all the students, right? Test scores, and this is going to be a particular student test score. So you can do that. Or just not to confuse anyone. I know sometimes I get OCD-ish about this. All right, so I'll just remove this and then I'll use students with S test scores. All right, this is going to be a particular student test score. Okay, all right. I don't like this S here, but just to clarify. All right, so target variable, this target variable current student test score is going to represent the index of the scores, and as long as the current student test score is less than the student test scores length. Now every array has a public field, okay, called length, that holds the length of the array. And so we are using the length of the array, okay, to check for this condition. Let me just construct the array and then we'll have a better sense of it. So int current student test score is equal to 0. As long as current student test score is less than student test scores dot length, current student test score plus. Okay. All right. So what we are doing here is I keep on thinking about this, right? The reason why, so now this makes it clear that, okay, now this is dealing with all the scores, and this makes it clear that we are dealing with one student score. I'm tempted to just remove this and keep it this way, so that you see this is going to actually help you understand it better. Even though they are the same, you'd be wondering why it still works. So I'll leave it, right, just so in future programs, if you, let's say, come across something like this, you understand that, okay, this is not the same as this. This is a parameter that this method is using, right? So I know I've gone back and forth trying to just mess with this S here or no S here, But let me just keep it this way, just so you understand that this is dealing with all the scores. This is dealing with a particular student test score, and this is not going to be an error because this method will know that this is a parameter of this method and not, it's not dealing with this. And again, these are two-dimensional. This is a two-dimensional array, and this is a one-dimensional array. So sorry for going back and forth, but I'm sure some of you are laughing by now, going like, this guy. Anyway, all right, that's fine. All right, so what we are doing here is we are making sure that we are basically looping through the student score array here. We are making sure that each element, okay, is valid. Each element, okay, has the right, okay, to be in this array. We are looping through it, checking to see if the particular element the particular index is not outside the range of the particular array. Current student score starts at 0. We are checking to see if 0 is less than the length of the array. For all the elements in the student test score array, okay, the index will always be less than the length of the array, okay, because we have 4 scores. According to this question, we have 4 scores. We have 4 scores. The first element has index 0. The second element has index 1. The last element will have index 3, right? So all of them, okay, will have indices less than the length of the array, which is 4. So you're looping through that. We're making sure that, we are dealing with numbers, okay, which have index, or we are dealing with figures in this array which have indices less than the length of the array, okay? All right. And so what we want to do is we want to grab each number and then add them up, accumulate them in a variable to get the total, right? We are going to use the current student test score value, okay, as it loops through this array to represent each element in the array. I'm going to come up here and then I'm going to create a variable that's going to represent the total of that particular student. And so it's going to be a double, all right, because the scores can be 56.8 or 78.5. When we add them, we end up with a double. So I'm going to create a double variable and I'm going to call it student test score total. A particular student test score total, or test score total. And so the student test score total in the loop, first of all, we initialize it to 0. We want it to have an initial value. So the student test score total is going to be equal to what's already stored in the student test score total plus the current element we are on. We are starting from the first element with index 0. We are checking to make sure that that element which has that particular element's index is less than the length of the array. If it's less than the length of the array, that means that particular element, we accessing basically a valid value, okay, in the array. We are not accessing any element that has an index that's more than the length of the array. And basically this means that anytime that the loop iterates once, before it goes up and check again if the current student test score is less than the student test score's length, you add 1 to current student test score. So the first time, current student test score will be 0. And then we are going to check to see if 0 is less than the length of the array, right? If it is, then that means it's a valid value. So let's go ahead and use that particular index to grab the element in that position and add it to total. And then once it does that, current student test score will be increased by 1. And then current student is going to be 1. We check to see if the current student, which is 1, is less than the student test score's length, which is 4. 1 will be less than 4. And so we use the 1, which is the current student test score index, to grab the particular element, okay, in that index, on that position. And then we add it to the total. We are basically grabbing the element in the array and adding it to total. Okay. And so once we make sure that this is a valid element in the array, we add it to total. Total starts off at 0. We are grabbing the first element, second element, and so on and so forth, all the way to the last. And so we reference the name of the array, student test scores, and then we use the particular index that we are on, the current student test score index that we are on, right? So current student test score, we are accessing that particular element in the array. What we are doing is basically saying take what's already stored in student test score total. All right, add it to the next or the current element that we are on in the iteration, and then store the total in student test score total. Okay, student test score total is going to be what's already stored in student test score total plus the value in that particular index. All right, it's been a while since I did this, so I'm a bit rusty, but hopefully I should get back in form soon. All right, so student test score starts off as the student test score total starts off at 0. Okay, and then we are adding the first number, okay, or the first score of the student to the total, and we are storing the result back in total. The next time the loop iterate, student test score total will have, the previous value. We are taking what's already stored in the total, and then we are grabbing the next element or the next score of the student, and we are adding it to the total and storing the result back into student test scores total, and so on and so forth. All right, so I hope you get it. I know I spent a lot of time on this, but hopefully you get it. Again, it's been a while, so I'm a bit rusty. All right, so once we have the total here, by the time this loop iterate adds all the elements or all the scores of the particular student, we'll have the total stored in student test score total. And so in order to get the average of that particular student, we take the student test score total, and then we divide it by how many scores, right? Or basically how many elements are in this array. There are scores in this array, so how many scores in this array? We know we can use this particular array's length property to get how many scores are in this array, right? So the student test score total divided by the student test scores length property, which gets to the length of the array. If there are 4 scores, we are adding all the scores up, and that will be stored in total. We are dividing by the length, okay, of the array. Okay, according to this question, it will be 4 scores, and then that will be our average. So I'm going to go ahead and create a variable here. I'm going to call it. It's going to be a double variable because the average can be a double. So I'm going to call it student test score average. And so the student test scores average is going to be equal to the average here. The average we just calculated here. Once we're done, let's go ahead and return the student test scores average, right? Because we said the method is going to return a double. So return student test scores average. All right, so we're done with this. So I know this was a bit, crazy, but we're done. Hopefully, everything is smooth going forward. All right. So the class should have methods that return a specific student's name, the average test score, and a letter grade based on the average. So we need to create a method that's going to return a letter grade based on an average. So again, that's also going to be a public method, no static method, no static keyword, because this method is going to be an instance method. All right, we need to specify the return type. This method here is going to return a letter grade based on the average. So it's going to return a character, right? If it's a letter grade, then it's going to be a character. So public char, okay, let's call it get student letter grade. Okay, it's going to be like a regular method apart from the keyword static. All right, so it said the letter grade based on the average. So that means that we need to pass into this method the average so that this method can determine the letter grade based on the average, right? So I'm going to define a double value because the average is going to end up being a double, and I'll call it student average or test score average. Student test score average. Test score average. Let's go through the variables and see if it makes sense here. So I defined a variable called student test scores total. Test scores total. Let's just say student test score total. Test scores total. And then student test scores average. Test score average. Yeah, we'll keep it this way. We'll keep it this way. Okay, it makes sense this way. But again, feel free to change it however you want. All right, so we give it the average, and then we return a character, or which is going to be the letter grade based on the average. And so I'm going to go ahead and create a variable, and I'm going to call it the student letter grade. It's going to be a character variable or a char variable. I'm going to call it student letter grade. Let's not initialize it for now. So we've been given the test scores and the letter grade here. Based on this, we're going to determine the letter grade, based on the average. So let's create an if else if structure for this to determine that. All right, so if, let's go ahead and create the structure. We are getting a letter grade based on the average. So if, the student test score average, that's what we are checking on. If the student test score average, let's start with F, all right, 0 to 59. All right, so 0 to 59. I'm sorry, someone was trying to get my attention. And this happens all the time, I'm sorry. Okay, so let's start with 0 to 59, F, right? So if the student score average, is less than 60. Anything less than 60, it can include negative numbers here. Later on, we will work on the input validation to make sure that students enter the number 0 to 100. And so we are assuming for now that anything less than 60 would be, 0 to 59, right? Less than 50, 0 to 59. The letter grade is going to be equal to F, right? So student letter grade is going to be equal to the character F. This is supposed to store a character, so we make sure we set it to a character. Okay, else if the student test score average, right? All right, so let's just think about this for a second. If the student test score average is less than 60, then the letter grade is F. If the student test score average is not less than 60, that it's not less than 60, then that means that value, is 60, or above 60. Now we don't want to check for all the numbers 60 or above. For all the numbers 60 or above, we want the ones that are less than 70, right? So if the number is not less than 60, that means it's 60 and above. For all the numbers 60 and above, or 60 or above, we want the ones less than 70. 60 or above, but also less than 70 gives us 60 to 69. And so in that case, your student letter grade becomes a D. And then we work on it that way, so on and so forth. All right, so again, let's think about it for a second. First of all, if your score is not, the average test score is not less than 60, right? That means it's 60 and above. For all the numbers 60 or above, we want the ones less than 70. So that gives us 60 to 69. So you get a D. If your score is not less than 60 and it's not less than 70, then that means the score is 70 or above. But we don't want all the numbers 70 or above. We want the numbers 70 or above, but also less than 80. So else if student test score, right, is less than 80, then the student letter grade becomes a C. There's a complete program on this. I'm not sure the number, but if you go through the program challenges in Java, you see a test scores program. I think there are a couple of them, and basically walk through this so you can get more understanding from that. All right, but it's basically the same. All right, so we'll keep on going the same way. I'll just copy this time around. So I'll see if the student test score is less than, let's check here 1 second. All right, so if your score is not less than 80, then that means that it's 80 or above. For all the numbers 80 or above, we don't want all of it. We want the ones 80 or above, but also less than 90. All right, so if that's the case, 80 or above, less than 90, it gives us 80 to 89. And that's the case, we have a B. Right? Else, if, right? You can also use an else, but let's just stick with an else if, and I'll explain the else in a second. So if your score is not less than 90, then that means your score is 90 or above. For all the numbers 90 or above, we don't want all of them. We want the ones less than or equal to 100, right? Including 100. Less than or equal to all the numbers. If it's not less than 90, it's 90 or above. For all the numbers 90 or above, we want the ones also less than or equal to 100. So 90 or above, but also less than or equal to 100 gives us 90 to 100. So else, if the student test score average is less than or equal to 100, then your student letter grade becomes an A. Okay. Wow, it's been a while since I did all this stuff, and so I'm really rusty. But hopefully, very soon, I'm pretty sure that I'll be on form soon. Okay. So don't worry. I know I'm a bit slow. I'm just trying to get this done well. All right. And so once we are done, okay, once whoever calls this method provides us the student test score average, this method here will determine the letter grade. It will assign the letter grade to student letter grade. And once we're done, we go ahead and return it, right? So let's just do that here. When we're done with the if statement, we go ahead and return the student letter grade. Okay, now I'm going to go ahead and compile this for now. Let's see if we have any errors. There is going to be one error here, and I'll explain that in a second. I also wanted to talk about if you wanted to use else. You can, right? You can, but if you use else, okay, if the score is not less than 90, then it's 90 or above. If you use else, then you're basically covering all the numbers that are 90 or above. We don't want to include 101. I mean, you can do that because at the end of the day, we're going to create an input validation for users to enter numbers 0 to 100, right? So that will still work. But I use else if, which also works perfectly. If you want to look at that program that works on the grading, trying to find the letter grade, I've done a couple of them in the programming challenges in Java, so feel free to go through them. I'm going to go ahead and compile this. It's going to be one error here now. I'll talk about that in a second. I'm going to go ahead and create a new folder here. I'm going to call this gradebook. Great, and I'm going to save this in here as gradebook.java. All right, so this was the error I was expecting. It says the student letter grade might not have been initialized. This value here that hasn't been initialized. Now over here we are dealing with if statement. So if, else, if. The only time that the student letter grade is going to be set to something is when this condition is true, or when this condition is true, or when this condition is true. If these conditions are not true, then student letter grade will be set to nothing. The program returns, it doesn't know what to return if that's the case. Okay, it's saying that there's a possibility that this value won't be set. And so in that case, when I'm returning this, I need to make sure that this is set to something at least. And so for now, let's just set this to the character Z. All right. Again, Z will never be used, but we are giving the student letter grade an initial value, so that when all these conditions are not set to are not true, when student letter grade is not set, it will return student letter grade as Z. The reason why we won't have D is we'll create the program in such a way that the value will be set. Okay, the number that the user is going to enter is going to be between 0 and 100. That's the point of the input validation. And when it's between 0 and 100, then one of these letter grades is going to be assigned to student letter grade. And so we'll never have to deal with student letter grade being set to Z. Okay, so compile this and it's fixed. All right. So let's continue. So we're done over here. Now it says demonstrates the class in a program that allows the user to enter each student's name and his or her 4 test scores. It should then display each student's average test score and letter grade.